So before we get started with doing any of this, what does it mean to substitute something? Yes? Okay, you take something out and then you put something else in. Does everybody agree with that? But it's a little bit more specific than that. Let's say in football, when you substitute, if you take out the quarterback, what do you have to put back in? A different quarterback, right? What would happen if you put a linebacker in? All right, so first of all, half of you don't know what that means. That means that you just put somebody from defense in who can't catch or throw in for the quarterback. Is that a good thing? So, it's even more important because he probably doesn't know the plays, right? So, it is very important that you not only take something out, but you put something of equal value back in, right? That's what happened to U of L the other day when Hunter Cantwell got hurt, right? They put in a quarterback that was not the same, and they started doing really bad. Okay, so same idea here. So let's start, first of all, by doing the most basic substitution. Y equals 4x plus 6, and y equals 2x plus 14. Okay? Do both of these equal the same thing? So are these equal to each other? Yes, they are. So this is a type of substitution because you're saying that these are equal to each other, just like we talked about. So if you're saying y is a quarterback, then here you have two quarterbacks. So what I'm going to do here, I'm going to subtract 2x from both sides. And you get 2x plus 6 equals 14. From there, you're going to subtract 6 from both sides, and you get 2x equals 8. Divide by 2 here, and x equals 4. Does everybody agree with that? So you should be pretty comfortable with this substitution because you've been doing these types of equations basically since the 7th or 8th grade. Right? These are just multi-step equations. So am I done? Why do I put in x? All right, I also need to know y. Does it matter which equation I use? No. So I'm just going to use the one that looks easier. I think the bottom one looks easier because it's an easier multiplication. Earlier I messed this up and I said 3 times 3 is 6. That was pretty sad. So let's see if I can do this right this time. So 2 times 4 is 8 plus 14. So y here is 22. Am I done? No, I still have to put it in an ordered pair just like we did yesterday. 4, 22. Sorry. Let's do one that is more of a real substitution. Y equals 2x plus 7. And 4x plus y equals 1. So, listen, I'm just going to tell you that it might be easier for you to solve it for y and then put it in your calculator. And that's fine. But I will tell you that it's better for you to learn this skill now than to try to figure it out later. Because later, if you want to go on to anything else, substitution is a really important thing. And especially in college professors think it's really easy, and it might not be that easy for you. But it's one of those things that they just think is like cake. So you want to be really careful about stuff like that so you don't get messed over later. So what we're going to do here, this is purple, right? Everybody agree that's the color purple? Yeah. So what I just circled in purple is equal to what? Is equal to y. So what I can do is I can take this one. I have 4x plus this 2x plus 7. And then I can set that equal to 1. So what did I do here? I took out y and put in y. Does everybody agree that those two things are the same? Okay. So there's no number in front of the parentheses, so I can just drop the parentheses off and get a 6x plus 7 equals 1. Does everybody agree with that? I subtract 7. I get 6x equals negative 6. So then x here equals negative 1. No, I mean negative 1. You have to divide by 6 on both sides. Sorry. Okay. So then, which equation am I going to put it into? The bottom or the top? I think the top one would be easier. It's going to get you the same answer, but I like to do what's easiest. It's always the best. 2 times negative 1 plus 7. So here y equals positive 5. So I have negative 1 and 5 for my intersection. So let's see how you're doing with this. I want you to do one on your own. I want you to do negative 4x plus y equals 6 and y equals x minus 11. So do this one on your own. Okay. So here what I'm going to do, I'm going to say negative 4x plus x minus 11 equals 6. So I'm going to have negative 4, negative 3, once I combine these two together, minus 11 equals 6. I'm going to add 11 to both sides. That gives me negative 3x equals 17. So x equals negative 17 over 3. Does everybody agree with that? So that's a little bit hard to read. This is our answer. So, luckily I don't really have to multiply too much here. Y equals x minus 11. So y equals negative 17 over 3 minus 11, which is negative 50 over 3. So our answer is negative 17 thirds 50 over 3. Yes? Oops, negative 50. Yeah. Where did I get the 3 from over there? Right here? That's a good question. If you remember, this is not just x. This is 1x. So negative 4 plus 1 is negative 3. So I saw a couple people that made that mistake. Anybody else have any questions over that one? Okay, so that's the first thing that can happen. There can be one solution. So let's look at another one. What happens if we have two equations that are in standard form? So our fourth one for today is going to be 2x plus y equals 4. And we're going to have 3x plus 2y equals 1. All right, earlier when people were trying out their work for the day, they were asking me questions about which one of these should I solve for the variable. Which one should I use? All right, the easiest one. Which is going to be the easiest one to solve? The first one, because I don't have to do any dividing here. I just subtract 2x from both sides, which gives me y equals negative 2x plus 4. Okay? So that's much easier. than going through this and getting 3 on the other side and then divided by 2 and getting 3 halves. And 3 halves is just messy to deal with.
Thank you.
Okay. So here what we're going to do, we have 3x plus 2 times negative 2x plus 4 equals 1. So again, remember the parentheses is what we know y to be, so we put that in. Okay, so what we're going to do, we're going to simplify this one. We get 3x plus negative 4x plus 8 equals 1. This part right here simplifies to negative 1x, and then the rest stays the same. I'm going to subtract 8 from both sides. I'm going to get negative 1x equals negative 7, and then x equals positive 7 after I divide by negative 1. Okay? Everybody agree with that? Good. So, I'm going to use this blue equation because that's the easiest one to use. Y equals negative 2 times x plus 4. So what I'm going to do, I'm going to say y equals negative 2 times that positive 7 that I found down here plus 4. So I have y equals negative 14 plus 4, which is negative 10. So my answer is 7, negative 10. Alright, so let's look at our last two. Firstly, we're going to have g plus 3h equals 8. We're going to have 1/3 g plus h equals 9. Okay, so here's what I'm going to do. I'm going to subtract 1/3 g from each side, and that gives me h is negative 1/3 g plus 9. So hopefully you're not freaked out by subtracting fractions from a side, but really, you just do it the same way you do numbers. You just move both numbers over. Okay? I'm going to put that back into the first one. So g plus 3 times negative 1/3 g plus 9. That equals 8. So what's 3 times 1/3? So then I have negative 1g plus 9, plus 27 equals 8. So this gives me 0g plus 27 equals 8. Right? So then that means we have 27 equals 8 because the g's fall off. So, remember this is 1 here. Is that ever true? So how many solutions does this have? How do we say that? We say no solution. So if it ever happens to where it cancels out like this, then there's no solutions. Because see, 27 can't ever equal 8. That doesn't even make sense. Okay? Everybody happy so far? Okay, good. One last one, and then we're finished. It actually ends up similar to this, but not exactly the same. We're going to have 2a minus 4b equals 6. We're going to have negative a plus 2b equals negative 3. Can anybody see anything special about these two equations before I even get started? Yeah. Okay, so if you multiply the one on the right, you don't just multiply it by 2, you multiply it by negative 2, and you get the one on the left. Does everybody agree with that? You don't? Okay. You're shaking your head now. Okay. All right, so let's go ahead and solve this one. I'm going to add a to both sides. Have 2b equals a plus 3. Yeah, thank you, minus 3. Well, I'll just do it plus negative. It's going to be easier in the long run anyway. Then I'm going to divide by 2. And I get that b equals a over 2 plus negative 3 halves. Why wouldn't the 2 be negative? Why would it be negative? See, it's a positive 2 right here. So when I divide by that, it stays positive. See, this is a negative over here, so I have to add. So this a becomes positive, so that's positive. This was negative to begin with, so it's still negative. All right, so what I'm going to do, I'm going to put that into this one for b. So I'm going to have 2a minus 4 times a over 2 plus negative 3 halves, and that's going to still equal 6. So just hang with me for another minute. We're almost done. So here's what happens. If you remember, we changed this to plus and negative 4. If you remember that from last year. If you don't, that's what you do to it. And then you multiply negative 4 through. So I have 4 times a over 2, or negative 4 times a over 2 is negative 2a. So I have 2a plus negative 2a. Then I have negative 4 times negative 3 over 2, which is plus 6. Then this 6 over here stays the same. What? 1/2 a? Yes, you can. All right, again, we end up with this weird thing, this 0a here, plus 6 equals 6. So now we end up with that 6 equals 6. Is that true?
Yeah.
How often is that true? Okay. So this isn't one solution. This is infinite solutions. So it is always true. The way that we say that something is always happening or always going on in math is infinitely. So this has infinite solutions. Are there any final questions before we get done? Of course you have homework.